My name is Mr. Hooker. Most of you probably know that at this point. We got to meet yesterday on the first day of school. Got to meet yesterday. If you weren't able to attend, but you're watching this video afterwards, my name is Mr. Hooker. Nice to meet you. Hopefully, we get to meet in person at some point. This is the first of my several to come instructional videos. Okay, so I want to talk a little bit about what an instructional video is going to, what the purpose of it is and why it's beneficial and what you can expect from them. Okay, so the instructional videos are going to be anywhere from like 10 to 20 minutes. They're basically like the first, 15 to 20 minutes of class, where I'm explaining what we're going to be going over that day, teaching you the stuff, and then a lot of times there's going to be like some example problems, okay? The advantages of these videos, a couple of things. The biggest thing in my opinion is, this video might be 20 minutes long, right? So if you need to take a break, right, or if something happens at your house and you need to get up and go take the trash out or something, or if you've got to go take care of your little sister for 30 minutes, right? You can just pause the video and you can come back to it later. Also, if you need to, like, let's say you watch the video and you're working on the assignment, but you forgot something I said, or you want to go back and listen to it again, you can, right? You can just go back to the video, watch it again. It's as easy as that. So, in many ways, like, virtual school is, it does kind of stink because you don't get to see all your friends and you don't get to, like, meet your teachers and get to know everybody. But there are some beneficial parts of it, right? Like, the videos could potentially be a better way to, like, learn the material, not necessarily, like, school overall, but it's not the worst it could be, right? And here at Douglas, we have like Chromebooks and we've been using Canvas for a long time, so we're better off than a lot of the state is when it comes to doing virtual learning, right? Okay, so let me show you some of the things that I have for the videos. So I've got this full webcam picture, right, with me in my room at my house, and I also can show you the slides that we're going to be looking at with my picture up here in the corner. Further down the line, I'm also going to be able to use this guy right here. Here, let me show you that a bit bigger. Okay, this is a document camera. Okay, so it starts looking like this and it folds up like this. This enables me to record with this little camera here whatever is underneath this. So I can actually write on a piece of paper or a notepad, and it kind of will work like a whiteboard. So whenever we get to the parts of the course where we start solving problems on paper, I can actually show you examples and walk you through them step by step, and that can happen on the videos or even in the Zoom meetings. So I think we're pretty well equipped to have a good start to the semester, and however long it takes for us to get back to in-person classes, I think we'll be able to learn plenty and do a good job at it. Okay, so I'm going to go ahead and get started here. I'll show you the title slide here, classification of matter. Before we even start talking about that, I want to just take a moment to explain to you guys what chemistry is. Okay, so I'm a chemistry teacher. You are in advanced chemistry. Most of you are probably sophomores. There's a couple of juniors and a few seniors, but mostly sophomores. And a lot of you had biology before this. Some of you may have had physics. And some of you may have had both. So biology is like the study of life, right? Things that are alive and living, so plants and animals and insects and stuff like that. So what is chemistry, right? And if we were in person, I'd be asking, does anybody know what chemistry is? And nobody would be saying anything because it's like the first day of school or whatever. So I'd have to wait for some brave person to actually say something. But we get to skip that part because we're doing this online. So chemistry is the study of matter. Okay, so you see here we're going to be talking about the classification of matter today. Chemistry is the study of matter. Okay, so what is matter? Once again, this would be one of those times where people don't answer because it's the first day of school. So we're going to go ahead and skip that again, and we're just going to dive right in here. Okay. Now, if you have a notebook, which I recommend, then I want you to actually go ahead and like take notes, like pretend that we're in class, right? Because we technically could be back as soon as October, right? In which case you're probably going to want to have these notes with you, and we're going to be taking notes on a regular basis. But even if we're not back in October, even if it's January or whatever, it's a good idea to take notes and to take this seriously. Okay, so if you have a notebook or even just a piece of paper, go ahead and get that now and pick up with me right here. So we're going to do a little bit of a activity here. So normally I would have you pair up, but we're doing this in a video. So by yourself, go ahead and make a 2-column table. So just 2 columns. Label 1 column matter and 1 column not matter. And then what I'd like you to do, okay, and just like pause the video when you get to this part here, I'd like you to try to sort each of these following substances into one of those 2 categories, right? Like what is matter and what is not, right? So chemistry is the study of matter. So let's see if we can figure out what things are matter and what things aren't. Okay, so like I said, pause the video here for a few seconds or for a minute or 2. See if you can figure this out. Okay, so what I want you to think about next is like what rules or reasons did you use for yourself, right? Like, for example, maybe you said, oh, in order for it to be matter, I have to be able to touch it, right? Like it's got to be like real, right? So maybe water counts as matter, maybe like bacteria, dust, but not sound, right? Or not heat, right? So think about that, right? There actually is a rule, or 2 rules really, for what determines whether something is matter or not. Okay. So the definition of matter is that matter is any substance that has both of these things. It's got to have mass, which means it has to weigh something, right? It's got to have, it's got to have mass, and then it has to have volume, meaning it has to take up space. Okay? So think about those 2 things, right? It's got to weigh something and it has to take up space. And go back to your table. You can either make a new table or you can just erase the things that you have written down. I want you to resort stuff, okay? And see how good you did, right? And when you figure out like where things go based on this rule up here, like what changed, right? And more importantly, think about like why did you have to change it, right? And I'm going to go back to this list here, and I'm going to tell you what things are and what things aren't matter. So in order for it to be matter, it has to have both mass and volume, right? So air is matter. Okay, air actually weighs a lot. Okay, if you think about you as a person, right, sitting outside on the planet Earth, all of the air above you is weighing down on you. Okay, and that's actually called like air pressure. So that's why when you are on the beach, for example, and you're at sea level, the air pressure is higher than if you're on top of a mountain. Because when you're on top of a mountain, you're literally higher up than you are when you're on a beach, and there's less air above you, less air weighing down on you, and so the air pressure is less than if you were on a beach. Air also takes up space because it's all around us, right? And you can actually feel air. If you like take your hand and like wave it through the air, you can actually feel it, right? So it has all those things, right? It takes up space, it has mass, you can feel it, it's definitely matter. Okay, moving down the list here, sound. Sound is not matter. Sound has no mass, sound does not take up space. Sound is something that moves through matter. It is a wave. that moves through matter, and your ears pick up the waves in air and like translate those waves into sound in your brain. Okay, but sound in and of itself is not matter. Neither is energy. Okay, because energy does not have mass. That's a little bit complicated. Maybe when you get to college or something and you start learning about some crazy physics stuff, energy and mass kind of do mean the same thing, but for our purposes, energy does not have mass, and it doesn't really take up space either. Water, definitely matter. It has mass, it takes up space. Light, very similar to energy. So light does not have mass, does not take up space, so we're going to say this is not matter. Heat is also very similar to energy and kind of like light as well, so heat is also not matter. Okay, this one's interesting. Space, and I say vacuum here, meaning like outer space, like the vacuum of space. This one takes up space because it's called space, but it does not have mass. That's what a vacuum is. It means that it's empty. So the vacuum of space takes up space, but there's no stuff there. There's no mass there. There's no weight there. So this would technically not be matter. Okay, this is an interesting one. A lot of people get this one wrong. Smoke. Smoke is actually made up of little tiny solid particles that are suspended in air. Okay, and like those little particles are like ash particles. So like when you see smoke like rising from a fire, it's the burnt, like let's say it was a campfire, right? The smoke is little tiny bits of ash that are coming off of the burning log, piece of wood, that have broken off and are suspended in air. And you may like that. That's why smoke is so bad for you to inhale it, because you're not just inhaling like air, but you're inhaling little tiny black pieces of stuff that can then like deposit themselves in your lungs, right? So if you've ever seen a picture of like black lung, which is like what people who smoke a lot of cigarettes can eventually develop, or even people who work in like coal mines can get that sort of thing as well. Not necessarily smoke, but same kind of principle. You actually do have things that have mass there, those little solid particles. And smoke takes up space, clearly. So smoke is definitely matter. Gravity. This is like a rule of physics, right? A rule of the way that the world works, right? Or the universe works. It's not exactly matter, right? It doesn't have mass, it doesn't take up space. It's more of like a concept or an idea. Bacteria, this one is definitely matter, right? Bacteria are little tiny organisms that definitely have mass and definitely take up space. Dust is kind of similar to smoke, so that one counts as matter. And electricity, this is a lot more like energy, light, and heat. Doesn't necessarily have mass or take up space, so this one would not be matter. Okay, so hopefully you got most of those right, or pretty close, and if you didn't, well, now you know, and hopefully it makes a little bit more sense to you. Okay, so mass and volume, those are the two important things there. So that's what chemistry is. Okay, the chemistry is the study of stuff. Okay, so it's the study of things that have mass and take up volume. So all the things that you can touch and feel and interact with as a human, that's what chemistry is. Okay, so like biology is actually like enveloped in chemistry, right? So like chemistry is almost like bigger than biology, right? So like everything that's biological, technically you could talk about in chemistry, right? And physics is like even bigger, right? So like physics gets into all the things that we talked on here that we didn't say were matter. So like sound and energy and light, heat, electricity, gravity, like all of those things you're going to talk about in physics. Okay. So let's talk about what the objective is going to be for today, though. Okay, so that's just sort of some general information about chemistry. Okay, specifically today, we are going to talk about how to classify matter. Okay, we've already sort of tackled this defining matter, but we're also going to talk about how we can classify matter into different categories, okay, according to like what it's made of and what it looks like. Okay, so that's our objective. I can define matter and classify it according to its composition. Okay, so before I get started with this, you have access to these slides. Okay, so when you, in Canvas, when you clicked on this link to watch this video, you have access to these slides. They're right above the video. So what I want you to do, if you don't have these slides up, I want you to go ahead and click on this, like open the slides and click on this link. Okay, this is going to take you to a graphic organizer, which you can see right here. And if you have a printer at your house, then I would like you to print this out. If you don't, that is totally fine. What I'd like you to do instead is just like draw this sort of shape looking thing on a piece of paper. Okay, it does need to be kind of big because we're going to be writing some stuff in these boxes. Like I said, if you can print this out as like a full piece of paper, that'd be the best. But if you can't, just get another piece of paper and make this. It doesn't have to look pretty, but it should look like this. And we're going to be writing some notes in these bigger boxes here. Okay, these can be kind of small up here. So can these down here. These boxes can be kind of small. These four here in the center need to be a little bit bigger for us to write in. All right. All right. Let me make this big again. There we go. All right. So matter, the stuff that we interact with in our world, can be classified as one of two big categories. Okay, and if I go back to this graphic organizer, what you're going to write up here in the top is matter. Okay, so like what we're going to be doing today is we're going to be learning how to sort any different piece of matter, okay, into one of these two categories, and then each of these categories has like two categories inside of it. Okay, so there's four total categories. So let me go back here. The two big categories are pure substances and mixtures. Okay, so when you encounter a substance, something in the universe, some piece of matter, it can be classified as either a pure substance or a mixture. Okay, so those are your two big categories off to each side. On the pure substance side, okay, so on the, for you guys, the left side, those pure substances can be one of two things. They can either be elements or they can be compounds. Okay, so those are the two, like, well, let me open this up for a third time. So you've got matter here, pure substance here, and mixture here. At the top of these bubbles here, you're going to want to put elements and compounds. Okay? So matter can either be a pure substance or a mixture, and the pure substances can be elements or compounds. And then over here, your mixtures can either be homogeneous or heterogeneous. Okay? So these are the two big categories, and then each of those has two smaller categories, so these are the four overall categories. Okay? And you can't have like a homogeneous pure substance. Like, that doesn't make any sense. And you can't have an element mixture. Like, that also doesn't really make any sense. Okay? So if it's a pure substance, it's one of these two. If it's a mixture, it's one of these two. Okay. Now what we're going to do is we're going to go through and actually fill in those bigger sections of the graphic organizer. Okay, so the part that I wanted you to make a little bit bigger, or if you printed this out, it should be plenty big. We're going to go ahead and write this stuff down, okay? And these are things I need you to know, all right? So we'll just go through this one by one. Mainly I'm going to be talking about the examples in each of these categories, okay? So elements, these are your most basic building blocks of the universe. If you came to school and picked up your materials, which were in those like brown paper bags, you should have gotten one of these things from me. This is, I think yours looks a little bit different than this. This is the one I use for AP Chemistry. This is a periodic table. Okay, this has all of the different elements listed on it, all of their chemical symbols. You have a copy of that for yourself. All of those elements, okay, found on the periodic table, those are what the universe is made of. Okay, so like everything in the universe, pretty much, there are some exceptions to this, okay? Everything in the universe is made of one or combination of those different elements, okay? So some examples, all right? C stands for carbon. H stands for hydrogen. You guys may know a lot of these. O is oxygen with nitrogen, phosphorus, and sulfur. I listed these six because these six elements here make up like 98% of your body. Okay, so 98% of your body is made up of six elements. Okay, so like all of your cells and like your DNA and everything that's inside of you, well, not everything, but 98% of what your body is made of is these six elements right here. Okay, some other things you have inside of you are like iron in your red blood cells. You have like various amounts of like sodium and potassium and magnesium and some other things, but those are the six big ones there. Okay, so that's also like the easiest one to understand, right? If it's just a pure element, like pure carbon or pure iron, it's definitely a pure substance, it's an element. Okay, your other type of pure substance is a compound, okay? Compounds are made of two or more elements together. And when I say together, keep in mind, it's not a mixture, right? So it's a pure substance still. Okay, so this is weird. So this is the one that always people always get like kind of hung up on. All right, so I'm going to do my best to explain it. Compounds are made of two or more elements. This really should say like connected together, okay, in a certain configuration. All right, so it's not just a big mixture of like two or more different elements. That would be one of these two over here, homogeneous or heterogeneous. Compounds, in order for them to be a compound, in order for something to be a compound, it has to have a chemical formula. Okay, and I've underlined this because this is very, very important, like for the remainder of our course. Compounds have chemical formulas. Here are some examples. H2O, water. Okay, H2O, that is a compound. It's two hydrogen atoms connected to a single oxygen atom. Okay. So if you have a glass full of water, each individual piece of the water is exactly this. It's two hydrogens and one oxygen. That's why compounds are considered pure substances, because if you were to dig into it and pick out random pieces, each piece that you pick out is the exact same, right? Even though that piece is made of multiple different things, right? Hydrogen and oxygen, each of those pieces is the same, just like an element, right? If you went into a bucket full of iron and you pick out all the different little pieces, it's all iron, right? Same thing with a glass of water. Every individual piece of the water is exactly the same, H2O, right? The hydrogens connect to the oxygen. Here's another one, NaCl. This is sodium chloride, also known as salt, okay? So table salt. And then those of you that had biology last year hopefully recognize this chemical right here, C6H12O6. This is glucose. Okay, so this is a sugar that your body uses as a source of energy. It is the source of energy. Okay, so no matter what you eat, your body generally tries to transform it in some way into glucose, and then it gets burned up in the cellular respiration process. Okay, so each piece of glucose is the same. It has 6 carbons in a ring with oxygens and hydrogens connected off of that carbon ring. Okay. All right, and then there is one little exception here, some special info. Some chemical formulas are going to look like a compound, but technically they're elements, okay? And I've listed 2 of the big examples here. O2, this is just oxygen, okay? So technically it's an element. It kind of looks like a formula, and it is a formula, okay? But it's an element. So it's kind of like squares and rectangles, right? Like all squares are rectangles, but not all rectangles are squares. All compounds have chemical formulas, but not all chemical formulas are compounds. Okay, that's kind of how it works. So these two are big examples, oxygen gas and nitrogen gas. These two things right here, by the way, make up like 97 or 98% of our atmosphere. Like the air that's around you right now is O2 and N2. You're breathing all of this in. This is the only part that actually interacts with your body, the O2. The N2, you just breathe it in and breathe it right out. It doesn't smell or taste like anything. Okay, so those are your pure substances, okay? Our mixtures, I think, are easier to understand and grapple with. Homogeneous and heterogeneous mixtures are the two categories. You probably recognize these prefixes right here. Homo meaning same and hetero meaning different. Okay, so for example, if if you are a heterosexual person, you are attracted to people that are of a different sex than you. If you are a homosexual person, you are attracted to people who are of the same sex as you, right? So, homogeneous mixtures are substances that have a uniform composition, okay, which means that when you look at them, the entire thing looks the same throughout when you inspect it, right? So when you go to look at the different parts of it, you can't really distinguish one place from another. Like it sort of just looks like you're all looking at the same thing, right? And that might sound like a pure substance, but it's not. So like, for example, you could have salt water, right? So if you pour salt into water, mix it up, the salt like dissolves in, right? And so if you took a really powerful microscope and you zoomed in to look at that salt water, you would see some water. You might see some salt. Actually, the salt breaks apart into its different parts, sodium and chlorine. Anyways, you would see some water, you'd see some sodium, you'd see some chlorine, but you wouldn't see like big chunks of salt off by themselves surrounded by water. Everything would be sort of like dispersed and spread out and well mixed is the way you can kind of think about it. Okay, air is another good example. Air is made of nitrogen, oxygen, and then lots of other things that are all well mixed, right? And you can look around, you can't see the stuff, right? It all looks the same no matter where you look. Some of the other big things in our atmosphere or in air, argon, which is number 18 on your periodic table, about 1% of the atmosphere is argon. And then you've got lots of other things like carbon dioxide, methane, small amounts of that, several other things that are in air, okay? Some key terms to look out for, okay, and I've underlined these. Make sure you write these down. If you see something that is referred to as a solution, it is guaranteed to be a homogeneous mixture, okay? So for example, salt water might be referred to as a saline solution, okay? If you have contacts, you know what I'm talking about. So a solution is by definition a homogeneous mixture, okay? Really it means a liquid homogeneous mixture. Well, technically it means a liquid mixed with water, okay? Okay, alloys, this is another thing that is by definition a homogeneous mixture. An alloy is a homogeneous mixture of metals, okay? So I have another example here, brass. I can never remember like what brass is. I should have written something else on here. So one that I can think of is bronze, actually, is made of copper and tin. Okay, so copper and tin are two elements. They're not connected together like a compound would be. Instead, the pieces of copper and tin, the atoms of copper and tin, are just like heated up, melted down, and mixed together. And mixed together, they make the metal or the alloy bronze. Okay, so that is an alloy, a homogeneous mixture. And then finally, we get to the heterogeneous mixtures. Okay, So heterogeneous mixtures are non-uniform in composition. These are the easiest ones to notice. When you inspect them, you can see the different parts. Okay, so non-uniform, meaning like you can see the different things that are inside of it. So a great example is like dirt, right? You pick up a fistful of dirt, and you might have some earth, right? Like earth. You might have like rocks. You might like have half a worm or something, piece of grass. Like you're gonna have different stuff in that handful, right? Cereal. I'm thinking of like Lucky Charms, right? Where you've got the like gray, disgusting part of Lucky Charms, but then you also have the yummy marshmallows. And then this one kind of confuses people. That's why I put it on here. Milk is technically a heterogeneous mixture. Now, as a human, when you look at it with your eyeballs, milk looks like it's homogeneous, right? But in order for something to be homogeneous, it has to be so well mixed that you can't even tell the difference with like the most powerful microscope that we have, right? Like an electron microscope or something. So milk, when you zoom in just with like a regular microscope, something that we might have in a biology classroom, you can actually see different stuff in your milk, right? There's like cells of things floating around in your milk, right? We still drink it, but it is not homogeneous, okay? It is heterogeneous. And especially if it stays in your fridge for too long, then it's definitely heterogeneous, okay? You know what I'm talking about. So, okay. Last thing I'd like you to do for today, and I know I'm going kind of long. I really am going to try to keep these videos shorter in the future, but, it's just fun to teach, I guess. So, all right, what I would like you to do is in the bottom part of that graphic organizer, right? So we just filled in some notes in the middle section. In those 4 bottom boxes, what I'd like you to do is think about what each of those 4 classifications would look like if you could see the individual little particles, okay? And my advice to you would be like use like little circles or little squares or little triangles. See if you can come up with something, okay? And once again, this is a part of the video where you just need to pause for a second, and here in just a moment I'm going to show you kind of some examples of what you could draw. Okay, so let's take a look at some examples here. So an element, right, is a pure substance, and every piece is exactly the same. Okay, so like this could be any element on the periodic table. It could be hydrogen, it could be nitrogen, it could be gold, it could be silver. Okay, this would technically be like a gas because they're all floating around and not really coming into contact with each other, but everything looks the same. Okay, this is our compound, right? And this could be, this looks like it might be carbon dioxide. So the little gray balls are carbon and the red ones are oxygen, C and then O2. This is still a pure substance, right? Because each piece is exactly the same as all the other pieces, even though the individual pieces are made of more than one element, right? They're just connected together in this constant arrangement. Okay, and then you get to the other side of the picture here, mixtures. There are 2 categories. A homogeneous mixture, right, which is well mixed. This might not look super well mixed to you. We just don't have that big of a picture. If it was really big, then it would probably look a little bit better mixed. This could be, for example, like something in air, right? This could be like O2, like 2 oxygens with, say, some argon or something like that. And they're just sort of floating around together, nice and well mixed. We're zooming down to the, super small scale here, and we still, see them nice and mixed together. In the heterogeneous picture on the other hand, there's like this boundary. You see how I can like draw this line here to like show that there's like one part of the mixture versus another part, like there's this distinct boundary. That's kind of what we're looking at here. So this might be like water that is on top of like oil or something, right? So you've seen like if you mix water and oil, they don't mix, right? It doesn't make a homogeneous mixture. It makes a heterogeneous mixture. You can see the different layers of the 2 different substances that are in the mixture, right? Okay, well, I think that is my last slide for you. Sorry that this went a little bit longer than I expected. I had some stuff at the beginning I wanted to talk about, so hopefully the videos in the future won't be as bad. So, like I said, the goal is to watch these videos before we get to class. I realize that might not happen for like the first week or so, but what that means is that you can ask me questions and work on your assignment during the Zoom meeting, and be able to ask me questions while I'm there, and not have to take like any work home with you. So, all right, thanks a lot for listening, and I will catch you next time.